What if I told you that by the end of this, you're going to have a mathematical superpower? No, I'm serious. You'll be able to look at stuff that's already happened and make a scarily good guess about what's coming next. Let's get to it.
I know. It sounds like something from a movie, right? Using math to see the future? Well, the answer is a huge yes. And believe it or not, the how is way simpler than you'd think.
So, to unlock this power, we got to understand that probability kind of has two different personalities. I like to think of it as the official rulebook versus, the instant replay from the actual game.
So on one side, you have theoretical probability. That's our rulebook. It's what should happen in a perfect world. A perfect coin should land on heads 50% of the time. But then, on the other side, you've got empirical probability. This is our game tape. It's what really went down when you actually did the experiment. It's messy, it's based on real data, and that is what we are diving into today.
Okay, quick textbook definition moment, just so we have it. Empirical probability is just the number of times the thing you wanted to happen actually happened, divided by the total number of times you tried. Okay, enough of that. Let's see this thing in action.
Let's start with a super relatable example. Imagine we went to a school and just asked a ton of students one simple question. What's your favorite subject?
And boom, here's our data. We talked to 400 students in total. And wow, it looks like social studies is the big winner here. But the real magic isn't just seeing who won, it's how we can turn these numbers into predictions.
So, let's zoom in on English. The data shows us that exactly 100 students picked it as their favorite.
To find the probability, it's actually super easy. We just take that number, 100, and we put it over the total number of students we asked, which was 400. That gives us a fraction, 100 out of 400. And if you simplify that fraction, you get 1/4, which, as a percentage, is 25%. And just like that, based on our game tape, we know there's a 25% chance that any random student here will pick English. See? Easy. As I'm looking at this, only 25 students picked math. I guess the other 375 just didn't get the summons. Get it? Summons? Come on, that was a good one.
So if we do that same simple math for all the subjects, we get this awesome chart. It makes it really easy to see the whole story at a glance. Social studies and that other category are definitely the heavy hitters in this school.
Okay, so surveys are cool and all, but what happens when we try this with something that's pure chance? Let's get a little dicey. So we took a normal 6-sided die, rolled it 30 times, and wrote down what we got. And, whoa, check this out. These results are kind of nuts. We rolled a 4 11 times, but a 6 only once? That feels off, right?
And it is off. Remember our rule book? Theoretical probability says a fair die should land on each of its 6 sides pretty much equally. You should have a 1 in 6 shot for any number, but our game tape here is telling a totally different story.
Honestly, rolling a 6 just one time in 30 tries, yeah, that's pretty much how I roll. Badly.
So, what gives? Is the die loaded? Well, probably not. And this gets to a really, really important idea. Sample size. 30 rolls is just not a lot of data. It could totally just be a weird fluke, a random lucky or unlucky streak. But if we rolled that same die 3,000 times and we still barely got any 6s, okay, then we can start to think something fishy is going on with that die.
So the big takeaway here is one weird experiment isn't proof of anything. In this case, it's just a small sample of my terrible luck. All right, so we know how to look at what's already happened and find the probability. Now for the really cool part, the superpower. Let's actually use this to look into the future. Let's circle back to our school survey. We have solid data there. We figured out that the probability of a student picking English is 25%. So here's the question. If we go out and ask 50 new students, how many of them can we expect will say English is their favorite?
This is a piece of cake. It's a simple 3-step move. Step 1, you find the probability you already calculated. So for English, that was 25%. Step 2, turn that percentage into a decimal. So that's 0.25. And finally, step 3, you just multiply that decimal by your new group of people, which is 50.
So you do 0.25 times 50, and you get 12.5. Now, obviously, you can't have half a person, so our prediction is that about 12 or 13 of those next 50 students will pick English. And there you have it. You just made a prediction using math. How cool is that? And just like that, you are officially a mathematical fortune teller. Your new name is Nostra Decimal. Yeah,
I know, I'll show myself out.
So let's just do a super quick recap of what you can now do. You get the huge difference between the rulebook and the game tape, right? Theory versus reality. You now know how to pull probabilities out of real-world data, and the best part, you can use that data to predict what's going to happen next. So I'll leave you with this thought. You now have a real-deal mathematical superpower. This is exactly how people predict the weather, how analysts predict who's going to win the big game, and how companies predict what you're going to buy next. It all comes down to looking at what happened before to predict what will happen next. So my question to you is, what will you predict first?